So the reflection that you've learned already is that you already know that what you're seeing is a mirror image. That's the word we use for a reflection if we were trying to describe it to somebody. All right. In order to have a mirror image, we need to have a mirror or a mirror line. All right. So mathematically, we need a mirror line. Now, the fact that in maths it's not quite the same as a mirror, because we can have things on either side of the mirror line, all right, and be reflecting to the other side. There are a few things that we need to know. We need to know that the lengths always stay the same. So it doesn't affect the size, but it does affect its orientation. It does affect how it is put on the page. We need to have the image and the original should always be the same length away from the mirror line. And I mentioned one other thing with translation, and it was about invariance, all right? And for invariance, we need to make, in reflection, what points don't move in reflection? What points will stay exactly where they are when we're reflecting an object? Ollie?
Any point that's touching the mirror.
Perfect. The invariant points are on the mirror line. Okay? They don't move. Okay, so let's have a look at a nice basic easy one. If I say the mirror line is here, and I have a shape that's here that looks like a backwards C. Same rules as before, I need to have a couple of letters on it so I know that that's my original shape. I'm going to reflect it in the mirror line, so every point has to be the same distance away. So A is going to go to here and become A dash. This was interesting in the diagnostic test because this is one that quite a few of you could do the easy but not the more tricky one, which was interesting. All right, so B is 3 squares away, B dash has to be 3 squares away. Okay, so that's a pretty straightforward one. We could have one that goes through the mirror line, so we could have it going like this. Here's my triangle that I am reflecting in the mirror line, which we usually write an M on, A, B, C. So this time I want to work out where B goes to. So it's got to go straight through the mirror line and be 2 squares away. 1, 2, 1, 2, B dash. 1, 2, 1, 2, A dash. And 1, C dash. And then join them up with a ruler. So I've got that picture. All right? Then it gets one step harder. Sometimes we're given a diagonal mirror line, like this. And they might give a point like this. This is the one that a lot of people get wrong. Right? This is A, this is B, and as Ollie said, these 2 points won't move. Okay? Those 2 points on the mirror line won't move. That's the part that gives us a hint. This one here has to be 1 square away. A lot of people, when they're reflecting this, they want to put it here. All right? Because that looks nice. But when we're reflecting, that is not right. We've got to go through the mirror line. This is where B is, 1 square away. through the mirror line. This is where A is, 1 square away. I mean 2 squares, but 1 square on the diagonal. So we actually end up with an image like that. So, next comes the tricky one. If there were no squares and I just decided this was the mirror line, and here was a shape, let's do a triangle again. Where does it go to? The thing that we have to realise is that we are going perpendicularly, that means at a right angle, through the mirror line. So the easiest way to do this is to grab a ruler and make sure that your ruler is going straight through. So here's my line. I need this to be at a right angle. And I need to know, so at a right angle, it's not too bad actually. It's 16 away. So if I put the image 16 away, it's almost at the same point by fluke. Right, it's about here. So the other one is going to be just further away on this side. Unfortunately, that one's gone almost at a right angle. This one here has to be at a right angle as well. We'd have to measure it. So we've got 5 centimetres. So my image is going to be here. Having this go straight through at a right angle. All right? So no matter how the line is drawn, we're always going straight through at a right angle and joining them up. So we've gone from here to here to here and down to here. And I'm going to put C, B, A dash and C dash, A dash, B dash. So, last thing is, if I've got a shape, this one, I'm not very good, well, I didn't draw, but trying, and an image, like this, approximately. It's hard to figure out, really. Okay. How do I find the mirror line? All right. What is the method for finding the mirror line? Ollie.
You could find how the shape's been rotated and transformed, and then you could find the difference between the 2 points and find the 2 individual points, and then find the mirror line on those 4 points, which you could do by finding the distance between one, 2, top 2, and then finding the between.
Yeah, that's exactly right. So it hasn't been rotated, it's been reflected. But if I look at this point and this point, and I join them up and find halfway, all right? That's where the mirror line's going to be. If I find this point and I join them up and find halfway, it would also be the same as if I did this one. Those points are all going to line, and draw it with the ruler, all going to end up on the mirror line. So these have to all be the same length. All right, so that's how you find a mirror line. So that might be the only bit that's new.